Question 3. So we want to construct a box with a square base. Okay, square base. So I've drawn this diagram. It's got a square base here. Okay, so that sets us up with our unknown. We only have 12 square meters, so that would select, that's area. It's not volume, so we've got to do something with area. We've only got that amount of material to use in the construction of the box. I guess we've got to presume that thickness doesn't come into it. We've got a set thickness, we don't need to worry about it. Assuming that all the material is used, so we've got no leftovers, determine the maximum volume that the box can have. Okay, so we've got to set up an equation, okay, using area. So that's the piece of information we've been given, and then we've got to work out a function that would tell us the volume that we can differentiate. So what I've done here, sorry, dodgy lines, is just show we've got a square base, but we've got then 4 of these. So we've got 4 of those. Okay, we've got 2 of those because we've also got one that will end up on the top. Okay, so if we set this as x, the area will be x squared. Okay. So when we start looking at these sides, we've got to use the information because it's not obvious straight away. Now, what I know though is that this area that's left over, or 4 lots of them, okay, will be 12 square meters minus our 2x squareds, one at the top, one at the bottom. And that's for all 4 of them, so therefore if I divide by 4 I get each one. Okay. Therefore if I know this side is x because it has to fit onto the base, okay, this side here that I'm going to try and find, well, this times this gives me this, so therefore this divided by x will give me this dimension. Therefore I can do 12 minus 2x squared over 4 and again divide by x. Well, that will be that dimension. Okay. We can simplify this a little bit and cancel out 2 out of here and here, so that will make 6 and 2. So I have 6 minus x squared all over 2x. This x doesn't cancel, this 6 doesn't cancel with the 2. We'll take out common factors only where we can. So now what we've got to do is go back and say we've got to find the maximum volume. So I found the dimensions, so we think x, and this one, this height here, will be 6 minus x squared over 2x. So the volume will be those 2 multiplied together. So x times x is x squared, and we've got to multiply by 6 minus x squared over 2x. Okay, so we can look at this and go volume is, brackets, expand the brackets, 6x squared minus x to the power of 4, still over 2x, which we can cancel. That will make 3. That will make that. So we end up with volume is 6x minus x cubed all over 2. Now we have to maximize this volume, so we are going to need to solve dv dx equals 0. So dv dx so far, well, maybe it's easier to write it's 3x minus a half x cubed, so that's just dealing with this 2 with the 6, but I've still got it on this term as well. So when I differentiate, I get dv dx equals 3 times a half, so it's minus 3 over 2 x squared. So we now need to solve 3 minus 3 over 2 x squared equals 0. So with this one we can do a bit of rearranging, so we get 3 equals 3 over 2x squared, because I've added the 3 over 2x squared to both sides. If I divide by 3 over 2, times 2 divided by 3, so that will be 2 equals x squared. Therefore x will be plus and minus the square root of 2. But of course, being a problem of actual dimensions, we're only going to use the positive square root of 2. So we've got x is 1.414 to 3 decimal places. Okay, let's just go back up and check our question. Construct the product, determine the maximum volume that the box can have. So we've got to put that value of x into our volume equation. Okay, so here is our volume equation. So let's put it in. So we've got volume is, well, square root of 2 actually, without rounding squared, will just be 2. Okay, multiplied by 6 minus, again, square root of 2 squared is just 2, nice and easy, all over 2 root 2. Right. So we end up with 2 times 4, 8 over 2 root 2, which will be 4 over root 2. And 4 over root 2 gives us an answer of 2.83 cubic meters to 3 significant figures. Just check, that's what we've got. Meters cubed, maximum volume the box can have. Yeah, so we found our x, which, just to confirm, x was a dimension. The volume equation we had to set up, didn't matter which one I put it in, but because I found out that x was the square root of 2, putting it into this one was nice and easy, because the square root of 2 squared is 2, and I had that there as well. So if I'd have put the 1.414 in, I would have got a slightly less accurate answer. I've still rounded anyway, but and does it make sense? Probably. We've only got 12 square meters to use. We've got getting on for 3 cubic meters, which, if you think about it, is quite a good size.